Have you ever wondered what would happen if the entire electric vehicle revolution, the one the world is pouring trillions of dollars into, suddenly became outdated overnight? Not because batteries got better, not because someone invented a supercapacitor, but because of something you drink every day, shower with every morning, and see every time it rains. That thing is water. In early 2026, inside a sealed room in Japan, with no cameras, no press, and no official announcement, a prototype was started up. The car had no lithium battery, no high-pressure hydrogen fuel tank, no charging cable, just a small water tank, a catalyst system, and the deep, powerful hum of an engine. Within 48 hours, what leaked out of that room wiped $17 billion from the electric vehicle stock market. Tesla plunged. Rivian lost its footing. Panasonic turned red. And all of Wall Street suddenly started asking the same question. Is this the end of electric vehicles? So, what exactly are we talking about here? Does a water-powered engine really exist? Or is this just another marketing stunt in an industry already famous for making massive promises? And if this technology is real, why did Toyota keep it secret for 17 years? Those are the 3 questions we are going to answer in today's video. Before we dive deeper into the story, if you enjoy deep dive videos about technology and the future of the car industry like this, subscribe to the channel and turn on notifications. Because what is about to unfold next could be the biggest technology story of this decade. The electric vehicle world, the dream, and the cracks beneath it. To understand why a water-powered car could create such a massive shockwave, we need to step back and look at the bigger picture of the electric vehicle industry over the past few years. From around 2015 to 2023, the world had almost agreed on one conclusion. The future belonged to electric vehicles. Governments poured hundreds of billions of dollars into subsidies. Elon Musk became the symbol of a new era. Giant battery factories rose across Nevada, Kansas, Europe, and China. Tesla's stocks soared to dizzying heights. Everyone, from Wall Street investors to suburban drivers in Michigan, believed there was only one direction forward. But beneath all that optimism, cracks were already beginning to appear. The first problem was lithium-ion batteries. This technology, even after major improvements, still carries built-in limitations. Batteries degrade over time, cold weather can reduce driving range by up to 40%. Fully charging a battery still takes anywhere from 30 minutes to several hours, depending on the charging station. And in 2024, electric vehicle fires became a major topic across the United States, especially after a series of serious incidents in underground parking garages in New York and Florida. The second problem was infrastructure. By the end of 2024, the United States had around 65,000 public charging stations. That may sound like a lot, but compared with more than 145,000 traditional gas stations, the number was still modest. And in rural areas, charging stations remained a luxury. A farmer in Iowa or a miner in Montana cannot wait half an hour to charge a vehicle in the middle of a work trip. The third problem, and this is the one people talk about the least, was the mineral supply chain. Lithium, cobalt, and nickel, the backbone materials of electric vehicle batteries, are being extracted at a heavy environmental and humanitarian cost. Congo supplies more than 70% of the world's cobalt, much of it mined under dangerous working conditions. Chile and Argentina are locked in heated debates over lithium extraction rights. And with China controlling more than 60% of global battery processing capacity, the question of energy security has become increasingly urgent for Washington. By 2024, awareness of these limitations was no longer just the opinion of a skeptical minority. It had become a mainstream topic in major newspapers like the Wall Street Journal, Bloomberg, and the Financial Times. Electric vehicle sales growth in the United States slowed sharply. Ford and GM began cutting their electric vehicle production targets. And right there, in the middle of the industry's uncertainty, Toyota saw an opportunity. But to understand why this matters so much, we need to look at the core of the entire story. Project H2X, Toyota's 17-year secret. The story did not actually begin in 2026. It began back in 2008. When the world was caught up in lithium-ion battery fever and all eyes were on Tesla's first electric cars. At that time, Toyota was at the top of its game with the Prius hybrid. the car that turned the Japanese brand into a global symbol of fuel efficiency. But while the rest of the world was chasing battery-powered vehicles, a quiet group of engineers inside Toyota's research and development division asked a different question. What if the energy source of the future was not electricity stored inside a battery, but a chemical reaction triggered right on the spot? The project was given the code name H2X. Its original goal sounded like science fiction. Build an internal combustion engine that could separate hydrogen from water in real time, burn it to create power, and release only one thing from the exhaust: water vapor. No high-pressure hydrogen tank like the Toyota Mirai, no massive battery like a Tesla, just water. By 2012, the research team had its first working prototypes. The early results were extremely promising. But then the project disappeared. No announcement, no explanation, just total silence. Engineers were reassigned to other departments. Documents were classified. 3 prototypes were placed inside a temperature-controlled storage facility in Aichi Prefecture. Insiders later revealed that the project was not stopped because of technical failure. It was stopped because of pressure from several directions. Oil companies were worried about a future where fossil fuels could be replaced. Toyota's hybrid partners did not want to see their own technology become outdated, and internally, there were even concerns that if this technology arrived too early, it could disrupt too many economic systems at once. That was 2012, and Project H2X sank into the dark. Then the world changed, in ways no one in 2012 could have predicted. Lithium batteries started showing their limitations. Cobalt mines in Congo became a global controversy. And more importantly, Toyota realized it had missed the first electric vehicle wave, which caused its market share in the United States and Europe to shrink significantly. In early 2026, Toyota's board made a decision. They would not compete with Tesla by building a better electric car. They would bet on something completely different. Project H2X was revived. The 3 prototypes were brought out of storage, and in just 5 months, with the help of newer components and modern materials, the engineering team achieved something they had never imagined they could reach so quickly. It may sound simple at first, but this one small detail could change the entire game. How the water engine works, the hidden science inside. Let's stop here for a moment, because to understand why this engine is creating such a shock, you need to know what it actually does. At the center of the system is a device Toyota engineers call the PTZO ultrasonic splitter. This is not a completely new idea in material science. Basically, the device uses high-frequency mechanical vibration combined with a special nanocatalyst to break the molecular bonds of H2O, separating water into hydrogen and oxygen. Here is the key point. This process happens in real time while the car's driving. There is no high-pressure hydrogen storage tank. There is no explosion risk from stored hydrogen. The vehicle creates just enough hydrogen to burn inside the combustion chamber continuously and on demand. The hydrogen is then sent into an upgraded combustion chamber capable of handling temperatures above 2,000 degrees Celsius. And what is the result of burning pure hydrogen? Not carbon dioxide, not nitrogen oxides, just water vapor. The same kind of vapor you see rising from your morning cup of coffee. Energy is not stored inside a lithium-ion battery, but inside a supercapacitor about the size of a lunchbox. This capacitor charges itself from the vehicle's own movement through regenerative braking, similar to a hybrid car, but much more efficient. In terms of real-world performance, the numbers reportedly shared inside Toyota are impressive. The car can go from 0 to 60 miles per hour in about 4.3 seconds, faster than most current midsize cars. Its top speed is 112 miles per hour, or about 180 kilometers per hour. Its driving range from a single water fill is around 760 kilometers, almost equal to a normal gasoline car and far beyond most mid-range electric vehicles. Water consumption? Around 5 liters per 100 kilometers. And Toyota claims the system can run on ordinary water, including tap water and even seawater, although seawater requires an extra pre-filtering step inside the treatment chamber. In terms of maintenance, one detail stands out. Because the only product of combustion is water vapor, there is no soot buildup and no carbon residue inside the combustion chamber. That means engine wear is about 42% lower than in a conventional internal combustion engine. Fewer oil changes, fewer piston replacements, lower maintenance costs. The cost to build the entire powertrain system for this vehicle is around $1,320. Compare that with the drivetrain of a Tesla Model 3, which costs close to $4,500. Compare it again with a lithium-ion battery pack in a mid-range electric vehicle, which costs around $8,000 to $12,000. That gap is large enough to rewrite the economics of the entire auto industry, but no matter how impressive a technology is, it means nothing if it cannot be produced at scale. The barriers nobody talks about the real challenges. This is the part many videos on this topic usually skip, or deliberately downplay, because the truth is, even if Toyota's water engine works exactly as described, the road from the lab to the street is still full of obstacles. The first barrier is materials. A combustion chamber that can withstand temperatures above 2,000 degrees Celsius requires special alloys that can resist corrosion in an extreme high-temperature steam environment. These materials are not rare, but today's global supply chain is not ready for mass production at that scale. Toyota estimates that material costs could push the price about 15% higher than a conventional engine during the early stage. The second barrier is regulation. Imagine you are an insurance company and a customer brings you a vehicle that is not an electric vehicle, not a hybrid, not a hydrogen fuel cell vehicle, and not a traditional gasoline car. What category do you put it in? What standard do you use to calculate insurance rates? One source from the American insurance industry said underwriters almost do not know where to begin with this type of vehicle. This is not just an administrative issue. It is a real barrier to commercialization. The third barrier is water itself. It may sound strange to say water is a problem, but remember that the United States is facing growing water challenges. California has gone through multiple severe droughts. Parts of the Southwest are running out of groundwater. If tens of millions of vehicles switch to water as fuel, what happens to urban water systems? Environmental experts warn that this question needs to be answered before the technology is rolled out widely. The fourth barrier is political pressure and special interests. When a new fuel source appears that threatens to replace not only gasoline and oil, but also lithium and cobalt, the corporations and countries that depend on those resources will not just sit still. The Texas oil industry has called this a PR stunt. Some American senators have already begun discussing regulations to control the use of water for transportation. This is not speculation. This is the political reality of every energy revolution in history. The fifth barrier, and maybe the hardest one to overcome, is market skepticism. Electric vehicles took more than a decade to build consumer trust. And even now, a large share of Americans, especially people over 45, still do not fully trust electric vehicles. Now imagine coming to them and saying, "There's a car that runs on water." How do you think they will react? Skepticism is not a bad thing. It is the necessary filter for every new technology. And this is exactly where the race becomes even more intense, because Toyota is not the only player trying to dominate the future of the car industry. The silent war who is winning and who is losing. The market reaction in the first 48 hours after the news leaked showed just how shocking this event really was. Tesla was the first name everyone looked at. And here's the interesting part: Elon Musk stayed completely silent. A man who comments on everything from Dogecoin to global politics suddenly had nothing to say about a technology that could erase the entire reason Tesla exists. According to internal sources, Musk ordered a temporary pause on Cybertruck powertrain improvements to reassess the market landscape. That is not exactly a sign of confidence. Rivian and Lucid, the two companies once expected to become the second and third Teslas of the world, are in an especially difficult position. Neither company has reached break-even. Both are burning cash quickly, and their entire business strategy depends on lithium batteries remaining the future of cars. If Toyota proves that assumption wrong, Rivian and Lucid may not have enough time left to pivot. GM and Ford are in a different position. They have enough resources to change direction, but they have just poured billions of dollars into battery factories. According to sources in Detroit, emergency meetings have already taken place. And the biggest question on the table is this: can we modify existing production lines to integrate hydrogen combustion technology, or do we have to start from zero? Japan was not surprised. They already knew. And now Japan's Ministry of Economy is trying to protect the technology from being stolen, something that is almost guaranteed to happen. Diagrams of the PTZO catalytic splitter were posted on a whistleblower forum by a group believed to be former contractor employees. Within hours, the documents were downloaded more than 4 million times. China has already begun reverse engineering the technology. India is approaching the issue differently. It wants to become the manufacturing hub. Leaked documents from a meeting between Indian government officials and Toyota's Asia-Pacific division show that the country is aiming to build infrastructure for water-powered vehicles, especially in rural and mountainous regions where fully electric vehicles are simply not practical. Russia has a completely different interest: military use. A vehicle that does not need fossil fuel, does not need electric charging, and only needs water would be a massive strategic advantage in conflict zones. According to sources from Moscow, the Kremlin has approved a fast-track research program to adapt this technology for military trucks and even underwater drones. Saudi Aramco lost $41 billion in market value in a single trading day. That number alone says everything you need to know about how serious the oil market believes this threat could be. So in the end, the biggest question remains: is this technology truly powerful enough to change the future? If it works, what will the world look like in 5 years? Let's imagine one possible scenario, not as a prediction, but as a way to understand the potential consequences if this technology is successfully commercialized. Toyota has submitted an internal roadmap to Japan's Ministry of Economy. The goal is 1 million water engines per year by 2027. If they reach that target, the rollout would begin in Asia and the Middle East, regions where electric vehicle infrastructure is still weak and demand for effective alternatives is extremely high. For American consumers, the best-case scenario looks like this. By 2028, American automakers begin releasing vehicles licensed with Toyota's technology. Lower cost than electric vehicles, longer range, and most importantly, you can fill up with water almost anywhere. For drivers over 45 who are used to filling a gas tank in 3 minutes and getting back on the road, the idea of filling with water in 3 minutes and driving another 760 kilometers is extremely attractive. But now look at the other side of the impact. If electric vehicles rapidly lose market share, what happens to the hundreds of thousands of charging stations already built? What happens to workers at battery factories in Ohio and Tennessee? What happens to electric vehicle technician training programs funded by the federal government? Technology transitions are never clean. There are always winners and people left behind. The electric vehicle revolution has created hundreds of thousands of new jobs over the past decade. A shift to water-powered vehicles would create new jobs too, but not immediately, and not necessarily in the same places or communities. There is one more scenario that few people want to talk about, the scenario where this technology does not succeed according to the roadmap. The history of the auto industry is filled with promising technologies that failed during mass production: compressed air cars, early solid fuel cell batteries, and even hydrogen fuel cell vehicles, the same technology Toyota once bet heavily on. The Mirai launched in 2014, and even today, it remains a niche product with extremely limited hydrogen refueling infrastructure. Could water-powered cars follow the same path? Absolutely. But the difference this time is that Toyota does not need a completely new infrastructure. Water is everywhere. That is the fundamental advantage no previous alternative vehicle technology has ever had. We have just walked through a huge story. From the cracks in the electric vehicle dream, to Toyota's 17-year secret, to the numbers that shook Wall Street, to the real barriers nobody wants to mention, and finally to the vision of a world where water becomes the fuel of civilization. This story matters not because it could make Tesla lose value. It matters because it resets the basic question of how we think about energy, resources, and geopolitical power. When lithium becomes scarce and turns into a bargaining weapon between major powers, a world powered by water becomes, in a very basic sense, a more equal world. Water cannot be fracked. Water cannot be monopolized by China's processing industry. Water cannot be controlled by OPEC. That is what makes this idea not just a technical revolution, but a revolution in the global order. But the future has not been written yet. There are still too many unknowns. Can PTZO technology survive mass production conditions? Can combustion chamber alloys be manufactured at an acceptable cost? Will politics and lobbying kill this project for a second time, just like they did in 2012? And the biggest question, the one none of us can answer today, is this. Is this really the turning point? Or 10 years from now, will we be sitting here looking back and asking, whatever happened to that water engine? Only time will tell. But one thing is certain. The race has started all over again, and the decisions made over the next few years will shape how humanity moves, produces energy, and competes for power in this century. So what about you? Do you believe Toyota's water engine is a real revolution, or just an interesting step forward that is not enough to change the game? How do you think Tesla and the electric vehicle industry will respond? Leave your thoughts in the comments below. Let's talk about it. And if this video gave you a new perspective, hit like to support the channel and subscribe so you do not miss the next deep dive. Because the story of the future of cars and energy is only just beginning.